Welcome back, students. In this class we will be studying about parabola. Now there are two types of parabolas that we will be focusing on. So one would be vertical type, the other would be horizontal type. Now foremost, let me start out with the vertical types. Okay. Now in vertical type, the form of the parabola is given to be as y is equal to a times of x negative h raised to the power 2 positive k. This is a quadratic equation. You have to know that. And the h and k that you see here is called the vertex of the parabola. And x is equal to h, which you see here, is the axis of symmetry of the parabola, or it is also called as the line of symmetry of the parabola. Now, this parabola which you see here can also be rewritten in the form of moving the k this side. Y negative k is equal to a times x negative h raised to the power 2. Or it can also be rewritten as b times of y negative k is equal to x negative h raised to the power 2. Where our b is 1 over a. So these are all different forms you have to know, and it is important that you understand the difference between vertical parabola and horizontal parabola. Now, since I mentioned the vertical parabola, the horizontal parabola, how does it look? The horizontal type. The form for this is x is equal to a times of y negative k raised to the power 2 positive h, and h comma k is the vertex of the parabola, and in this case y is equal to k is the axis of symmetry. Now, having said that, let us move on and study about the directrix, the focus, and the lectus rectum. Now, I'm going to draw a parabola. This is a vertical parabola. And there are two important things that you have to know. Now, this point is called the focus. Now, what is the focus? Focus is the fixed point in the parabola. Now, there is another thing you all have to know, which is called the directrix. Now, what is the directrix? Directrix is the fixed line in the parabola or of the parabola. So these two things are very important. Now, this point which you see here is called the vertex. Okay, so let me write it down here. It's called the vertex. Now, in this case, the vertex is 0, 0. Now, the distance between the vertex and the directrix, the distance between the vertex and the focus is always same, and it is given to be as p and p. So these two distances are going to be the same. Now, having said that, you should also know that we call the focal length to be as P. So that is very important that you have to know. So having obtained that information, there is one such information that you will have to know, and that is the focal chord. Now, what is the focal chord? The focal chord is the total distance from a point on the parabola which is running through the focus and hits the other point. So that is called the focal width. It is also called as the focal diameter. It is also called as the focal chord. It is also called as the focal rectum. It is also called as the lactus rectum. So these are the different meanings or different words for the same concept. Okay. And in this case, the distance between F and any point over here, that is going to be 2p, and similarly the distance between F and a point here on the other side of the parabola, and that is also going to be 2p. So in this case, if I were to take this as x-axis and y-axis, the vertex is at 0, 0, and this is actually the line of symmetry. Okay, the axis of symmetry that divides the parabola into two parts, and we have got the focal length, which is p units. The focal width is 2p units. So if I were to write the focal width for this particular parabola, it is going to be 4p. Okay, and the vertex, if I were to write it, it's going to be 0, 0. The focal length for this is going to be p units. The directrix is given by whatever the point, or in other words, whatever value that the line crosses through, that would be the directrix. Okay, we don't know here, so the directrix form would be in this fashion. So having said all these, having obtained all this, if you were to write the equation for this parabola, this is a vertical parabola. So as I mentioned to you, the form of the parabola in this case is y is equal to a times x negative h raised to the power 2 positive k. H comma k is a vertex, right? And we know the vertex is 0, 0. So 0, 0 is a vertex. So the form of the parabola is going to be y is equal to a times, and we know that the value of h and k are 0, 0. So it's going to be x raised to the power 2. So this is going to be the equation of the parabola. Now, we know that the focal width is 4p units, so therefore the value of a, now a is equal to 1 over 4p. Okay, have that in mind. A is equal to 1 over 4p. So if I were to write the equation of the parabola, the equation, I'm going to place it here, equation, required equation of the parabola in this case is going to be y is equal to 1 over 4p times x squared. So that is the required equation of the parabola. Now, if they give you the value of p, okay, if they say that if focal length is 3 units, okay, then the equation of the parabola would be y is equal to 1 over 4 of 3 units times x squared. So that would mean y is equal to 1 over 12 times x squared. So this is going to be the equation of the parabola in this situation. So that completes a brief introduction to parabola. Students, in this class we will also look into about the horizontal parabola. Now if we were to draw the horizontal parabola, the parabola would be something like this. So this is the x-axis, y-axis. So the vertex is at 0, 0. So this is the vertex, and the focus is present here, and the directrix is the line, vertical line, which will be flowing like this. This is the directrix. It's a fixed line, as I mentioned to you. Okay, and the equation of this line will be x is equal to, depending on the point in which it passes through. Okay, so the distance between the directrix and the vertex will be p units. Okay, and the distance between the vertex and the focus will also be p units. The distance between, or in other words, the focal width will be this is the focal width. Okay, that's the total focal width is going to be, if I were to write the focal width is also called as the lactus rectum or focus, or you can also call it as focal rectum. In this case, the focal width is given to be as 4p, and the focal length is p units. Okay, so this is the rough diagram for the horizontal parabola. The form of the parabola is going to be x is equal to a times y negative k raised to the power 2 positive h. The value of a is given as 1 over 4p. So if I were to take this as 1, therefore 1 can be rewritten as x is equal to 1 over 4p times y negative k raised to the power 2 positive h. Now I can also rewrite this as x negative h is equal to 1 over 4p times y negative k raised to the power 2. And it can be further rewritten as 4p times x negative h is equal to y negative k raised to the power 2. So these are the different forms in which we would be able to write the parabola. And of course the vertex is given to be as h comma k. The axis of symmetry for this parabola is y is equal to k. So this is the axis of symmetry. Okay, so axis of symmetry is a line that divides a parabola into two equal parts. Okay, so have that in mind. So having said these things, let us move on. Students, in this class we are going to be seeing about parabolas with negative coefficients. So I have already mentioned to you the form of a vertical parabola. So y is equal to a times x negative h raised to the power 2 positive k. This is the form of the vertical parabola. Now if a is negative, then the parabola's form would change. So that would be something like this. So I'm going to be drawing it here. This is the x-axis, y-axis, x-axis, and instead of the parabola being U-shaped, the parabola will be inverted U-shaped. So it is going to be something like this. Okay, if I were to take this is the vertex for this parabola. So the focus is going to be somewhere over here. The directrix will be flowing over here. This will be the directrix. As I mentioned to you, directrix is a fixed line. So the distance between the directrix and the vertex is p units. The distance between the vertex and the focus will also be p units. And the lactus rectum, or the focal width will be this point to the focus. Okay, this is half of it. So the total would be, this is going to be 2p and this is going to be 2p. Right, so this is represented in this form. Now if I were to rewrite this, I can rewrite this as y negative k is equal to negative a times x negative h raised to the power 2. This is one way to write it, and clearly we know that a is equal to 1 over 4p. This is the value of a. Now if I were to substitute it here, it's going to be y negative k is equal to 1 over 4p times x negative h raised to the power 2. I can cross multiply and write this as 4p. I can take the negative sign along with that. So it's going to be y negative k is equal to x negative h raised to the power 2. So the vertex is going to be h comma k. The axis of symmetry is the line that divides the parabola into two equal parts. So the axis of symmetry, or the line of symmetry, in this case is going to be x is equal to h. So when a has got a negative sign, the parabola gets inverted. So that is for the vertical parabola. We will now study about the horizontal parabola with negative coefficient. Students, in this class we will study about horizontal parabola with negative coefficient. If you remember, I have given you the form of the horizontal parabola, which is going to be y negative k raised to the power 2 positive h. The value of a becomes negative in case of horizontal parabola. So the shape of the parabola would be like this. So this is x-axis, this is y-axis. It's going to be hitting the vertex and moving out like this. So this is the vertex. In fact, with a being positive, it's going to be C-shaped, but a is negative, so it's C in the reverse fashion. And this would be the focus. This would be the directrix flowing. So that's the directrix, and its equation would be x is equal to whatever value that it hits here. So the distance between the vertex and focus, and the distance between the vertex and the directrix, that is always going to be p units. Okay, so this is p units and this is p units. So the distance between the focus and a point on the parabola, so this is actually the focal width. The focal width, this is going to be 2p here, this is going to be 2p here. So this entire thing is a focal width. Okay, now having obtained all this, the axis of symmetry is the line that divides the parabola into two equal halves. So from here we would rewrite this in the following way. So this can be rewritten as x negative h is equal to negative a of y negative k raised to the power 2. Of course, the value of a is 1 over 4p. I can rewrite it there. So this is going to be x negative h is equal to negative 1 over 4p of y negative k raised to the power 2. I can move this 4p to the other side. I can carry the negative sign with me, and that's going to be negative 4p times x negative h is equal to y negative k raised to the power 2. So this is the form of this parabola. Now the vertex in this case is going to be h comma k, and the axis of symmetry in this case is going to be y is equal to k. So you obtain the axis of symmetry from this equation, okay, from here, specifically with the right side, which is y negative k raised to the power 2. So having completed the parabola's different cases, we will now head to doing questions on them. Students, in this class we will be studying about the different types of parabolas and how to find their vertex, their focus, the directrix and the lactus rectum. So first we will study about y negative k raised to the power 2 is equal to 4a times x minus h. Now this is a parabola which has a degree as 2 for the y variable. Now a is positive and the degree of y is 2. So it is a C-shaped parabola. Okay. So what we will do is we will draw the parabola. So let us do that. So this is the x-axis, this is the y-axis. Now clearly the vertex, if you see here, is located at h comma k. So that means it is not at the center, so it can be somewhere over here. So let us assume this to be as h comma k, and let us draw the parabola. Okay, so this is the vertex. Assume that this is the vertex h comma k, and you're going to have the focus over here and the directrix over here. So let me draw the directrix, and this is going to be the axis of symmetry. Okay, now the important point here is to find the focus. So what is the focus if h comma k is a vertex? The focus is given to be as h positive a comma k. Remember that. And the directrix, to obtain the directrix, the equation of the directrix is going to be x is equal to h negative a. Now the form is 4a. Now this quantity which you see here, this is going to be giving you the lactus rectum. So the lactus rectum is 4a. Now the axis of symmetry, that is another important aspect here. So the axis of symmetry is cutting the y-axis. So you need to know at what point. Definitely it's going to be passing through the focus and intersecting the y-axis. So the axis of symmetry in this case is obtained from here. Okay, y is equal to k. So that's all. This completes the solution. If we have to give you a parabola like this, so these are the important points. So once you get point 1, 2, 3, 4 and 5 and draw the figure. A rough sketch is enough, and that completes the solution if they were to ask you this question. So let us move on. Students, we are given this case 2, y negative k raised to the power 2 is equal to negative 4a x negative h. Now clearly this is a C-shaped parabola, but only thing is that because of the negative sign, the orientation would be reversed. So if I were to draw the x-axis and the y-axis, if I were to imagine this to be the vertex and the parabola maybe hits and goes like this. Okay, so let me take this as the vertex. So this is h comma k, and we will be having the focus somewhere over here. and the directrix would be somewhere over here. So directrix will be passing like this, and this is my focus, this is the vertex, okay, and this will be the lactus rectum. Okay, lactus rectum would be this, and we know the lactus rectum is going to be equal to 4a, and the vertex is going to be h comma k. Okay, and the axis of symmetry will be dividing the parabola into two equal parts. So it would be cutting it like this. So axis of symmetry in this case is y is equal to k. So now the focus is obtained by this form, h negative a comma 0 positive k. This is the focus, and the equation of the directrix is given by x is equal to h positive a. So in the former case it is x is equal to h negative a, in this case it is x is equal to h positive a. So we have obtained all the important informations which we needed, and these important information would ensure that you complete this question. So we will move on. So students, we will be looking at this parabola x negative h raised to the power 2 is equal to 4a times y negative k. If you see here, the degree of x is 2, it's quadratic in form. So we are looking at a U-shaped parabola, remember that. So this is a U-shaped parabola, and a is positive. Okay, so this is the reason it is U-shaped. Okay, so I can just say that a is positive. So if we were to draw this parabola, it would be something like this. So imagine it is flowing like this over here. So this is the vertex, and this is the focus, and we would have the axis of symmetry cutting the parabola. Okay, so this will be the axis of symmetry. So it divides the parabola into two parts. So since the focus is over here, the directrix would be over here. So this would be the directrix. And of course this will be the lactus rectum, or the focal width. So let us write down the values for this particular parabola. So clearly the vertex in this case is h comma k, that's a vertex. Now to get the focus, you will have to have this coordinate in mind, 0 positive h comma a positive k, and the axis of symmetry. So the point where the line divides and intersects the x-axis, so that's going to be x is equal to h, and the equation of the directrix negative a, that will be the equation of the directrix, and the lactus rectum in this case is going to be 4a units. So this is the information that they want, and if you could provide all these informations, then you complete the question for this parabola. Okay, now let us see about the next case. The next case is case 4, where the form of the parabola is x negative h raised to the power 2 is negative 4a times y negative k. So a is negative, so that means the shape is inverted U shape. So if you were to draw the parabola, it would be something like this. Okay, so the vertex would be over here, h comma k, the focus. This will be the focus, and the directrix would be over here. So this will be the directrix. So if you were to stretch this line, this is the directrix, and this will be the focal width, or you can call it as the lactus rectum. Okay, the axis of symmetry will divide, so it will be dividing the parabola into two parts. So if we were to write all the information, so we can start by writing the vertex. Vertex is h comma k. The focus is given to be as 0 positive h comma negative a positive k. That's very important. The axis of symmetry, is x is equal to h. The equation of the directrix, is given to be as y is equal to k positive a. The lactus rectum is 4a. So providing all this information will ensure that you complete the question.